Hello children, let us start quadratic equations. In our previous classes, we have studied quadratic equations with real coefficients and real roots. In this chapter, we will add two more variations. First is real coefficients and complex roots, and the second one is complex coefficients and complex roots. Now let us understand real polynomial and complex polynomial. First one is real polynomial. A polynomial given by fx is equal to a0 plus a1x plus a2x square plus and so on up to an x to power n is called a real polynomial if its coefficients a0, a1, a2 and so on up to an as well as variable x both are real numbers. Similarly, a polynomial given by fx is equal to a0 plus a1x plus a2x square plus and so on up to anx to power n is called a complex polynomial if its coefficients a0, a1, a2 and so on up to an as well as variable x both are complex numbers. Degree of a polynomial. A polynomial given by fx is equal to a0 plus a1x plus a2x square plus and so on up to an x to power n. Whether this is a real polynomial or complex polynomial is called a polynomial of degree n. For example, x cube plus 2x square plus 3x plus 7 is a polynomial of degree 3. Here we see highest power of the variable. 2x square minus x plus 5 is a polynomial of degree 2 as the highest power of the variable x is 2. A polynomial of degree 1, 2, 3 and 4 has a special name. A polynomial of degree 1 is called linear polynomial. A polynomial of degree 2 is called quadratic polynomial. A polynomial of degree 3 is called cubic polynomial. And a polynomial of degree 4 is called biquadratic polynomial. Polynomial equation. If fx is a polynomial, then fx is equal to 0 is called a polynomial equation. If fx is a quadratic polynomial, then fx is equal to 0 is called quadratic equation. General form of quadratic equation is given by ax square plus bx plus c is equal to 0, where a is not equal to 0. Coefficients a, b, c and variable x may be real or complex numbers. Roots of an equation. The values of the variable that satisfy a given equation are called its roots. So if x is equal to alpha is a root of the equation fx is equal to 0, then f alpha is equal to 0. Solution set. The set of all roots of an equation in a given domain is called the solution set of the equation. So a set consisting of members 1, 2 and 3 is the solution set of the equation x cube minus 6x square plus 11x minus 6 is equal to 0. Fundamental theorem of algebra. Every polynomial equation fx is equal to 0 has at least one root, real or imaginary. Every polynomial equation fx is equal to 0 of degree n has exactly n roots, real or imaginary. A quadratic equation has exactly two roots. If it has more than two roots, it becomes identity. So in quadratic equation, ax square plus bx plus c is equal to 0, a is equal to 0, b is equal to 0 and c is equal to 0. Now let us see quadratic equations with real coefficients. Consider a quadratic equation ax square plus bx plus c is equal to 0, where a, b and c are real and a is not equal to 0. We will find a formula to calculate its roots. Take a common. So inside the bracket it is x square plus b by ax plus c by a. This can be rewritten as x plus b by 2a whole square plus c by a minus b square by 4a square. This means either a is equal to 0 or this whole is equal to 0. Since a is not equal to 0, so this whole is equal to 0. That means x plus b by 2a whole square plus 4ac minus b square upon 4a square is equal to 0. Take this to other side of the equation. So it is x plus b by 2a whole square is equal to b square minus 4ac upon 4a square, or x plus b by 2a is equal to plus minus under root b square minus 4ac upon 2a, or x is equal to minus b plus minus under root b square minus 4ac upon 2a. So the two roots will be minus b plus under root b square minus 4ac upon 2a and minus b minus under root b square minus 4ac upon 2a. Just now we have seen that roots of a quadratic equation are given by the formula minus b plus under root b square minus 4ac upon 2a and minus b minus under root b square minus 4ac upon 2a. b square minus 4ac is usually represented by letter capital D, which is known as discriminant of the quadratic equation. So roots can be written as minus b plus under root d upon 2a and minus b minus under root d upon 2a. We will consider four cases here. Case 1 when d is equal to 0. Case 2 when d is greater than 0 and perfect square. Case 3 when d is greater than 0 but not perfect square. And case 4 when d is less than 0. Case 1 when d is equal to 0. So under root part will be 0. So alpha is equal to beta is equal to minus b by 2a. Roots will be real and equal. Case 2 when d is greater than 0 and perfect square. So under root will go away. Roots will be rational and unequal. Case 3 when d is greater than 0 but not perfect square. That means under root will remain. So roots will be irrational and unequal. One important point to note here is irrational roots occur in conjugate pairs. That is, if one root is p plus under root q, then the other root will be p minus under root q. Case 4 when d is less than 0. That means b square minus 4ac is less than 0. So both the roots will be imaginary roots and they are given by minus b plus I under root 4ac minus b square upon 2a and minus b minus I under root 4ac minus b square upon 2a. One important point to note here as well is complex roots occur in conjugate pairs. That is, if one root is p plus iq, then other root will be p minus iq. That means alpha is equal to beta bar and beta is equal to alpha bar. Now let us see quadratic equations with complex coefficients. Consider the quadratic equation ax square plus bx plus c is equal to 0, where coefficients a, b and c are complex numbers and a is not equal to 0. Roots are given by the same formula, and that is minus b plus under root b square minus 4ac upon 2a and minus b minus under root b square minus 4ac upon 2a. Replace b square minus 4ac by discriminant d. So roots can be written as minus b plus under root d upon 2a and minus b minus under root d upon 2a. We will consider only two cases here, when d is equal to 0 and when d is not equal to 0. We will not consider when d is greater than 0 or when d is less than 0, as we know that the inequality is not defined for complex numbers. Case 1 when d is equal to 0. So complex roots will be equal. Case 2 when d is not equal to 0, complex roots will not be equal. Two important points to note here is, point number 1, in case of quadratic equations with real coefficients, complex roots occur in conjugate pairs. And point number 2, in case of quadratic equations with complex coefficients, complex roots may not be in conjugate pairs. For example, 4x square minus 4ix minus 1 is equal to 0 has both roots equal to 1 by 2i. Here coefficient of x is complex and that is minus 4i. If two roots of a quadratic equation are alpha and beta, then the quadratic equation is given by x minus alpha into x minus beta is equal to 0, or x square minus alpha plus beta into x plus alpha beta is equal to 0. Here alpha plus beta is sum of the roots and alpha beta is product of the roots. Now let us see conditions of common roots of two quadratic equations. We will consider two cases. Case 1, when only one root is common, and case 2, when both roots are common. Case 1, when only one root is common. Suppose alpha is the common root in two quadratic equations, a1x square plus b1x plus c1 is equal to 0 and a2x square plus b2x plus c2 is equal to 0. So x is equal to alpha will satisfy both the equations. We can write a1 alpha square plus b1 alpha plus c1 is equal to 0 and a2 alpha square plus b2 alpha plus c2 is equal to 0. Applying Cramer's rule, we can write alpha square upon b1 c2 minus b2 c1 is equal to alpha upon a2 c1 minus a1 c2 is equal to 1 upon a1 b2 minus a2 b1. We will study Cramer's rule in detail in determinants chapter. From this and this, we can write alpha is equal to a2 c1 minus a1 c2 upon a1 b2 minus a2 b1. And from this and this, we can write alpha is equal to b1 c2 minus b2 c1 upon a2 c1 minus a1 c2. So the condition for one common root is cross multiply. So we get a2 c1 minus a1 c2 whole square is equal to a1 b2 minus a2 b1 into b1 c2 minus b2 c1. Case 2, when both roots are common. Condition is given by a1 by a2 is equal to b1 by b2 is equal to c1 by c2. You need to keep in mind these two conditions. Now let us solve some questions based on what we have learned so far. First question, if alpha beta are the roots of the equation x square plus px plus q is equal to 0, then minus 1 by alpha minus 1 by beta are the roots of the equation. These are the options given. It is given that alpha beta are the roots of the equation x square plus px plus q is equal to 0. This quadratic equation is in the form ax square plus bx plus c is equal to 0, where a is equal to 1, b is equal to p and c is equal to q. So sum of the roots alpha plus beta is equal to minus b by a, and that is minus p by 1. So it is minus p. Product of roots alpha beta is equal to c by a. So it is q by 1. So it is q. To get the quadratic equation whose roots are minus 1 by alpha and minus 1 by beta, we will find sum of the roots and product of the roots. So sum of the roots minus 1 by alpha and minus 1 by beta is given by minus alpha plus beta upon alpha beta. We will put value of alpha plus beta and alpha beta from here. So sum of the roots is p by q. Product of the roots minus 1 by alpha and minus 1 by beta is 1 by alpha beta. Value of alpha beta is q. So product of roots is 1 by q. So the quadratic equation whose roots are minus 1 by alpha and minus 1 by beta is given by x square minus sum of roots into x plus product of roots is equal to 0. Sum of roots is p by q and product of roots is 1 by q. So the quadratic equation is qx square minus px plus 1 is equal to 0. So the correct option is option D. Second question, the equation of the smallest degree with real coefficients having 1 plus I as one of the roots is. These are the options given. It is given that 1 plus I is one root of the equation. So the other root will be its conjugate, and that is 1 minus I. As we know that the complex root exists in conjugate pairs. To get the quadratic equation, we will calculate sum of the roots and product of the roots. Sum of the roots is 1 plus I plus 1 minus I. So it is 2. Product of the roots is 1 plus I into 1 minus I. This is in the form a plus b into a minus b. So it is a square minus b square. Value of I square is minus 1. So the product of roots is 2. So the quadratic equation will be x square minus sum of the roots into x plus product of the roots is equal to 0. Sum of the roots is 2 and product of the roots is 2. So the quadratic equation is x square minus 2x plus 2 is equal to 0. So the correct option is option B. Third question, the number of real roots of the equation x square plus 5 mod x plus 4 is equal to 0 is. The given equation is x square plus 5 mod x plus 4 is equal to 0. Critical point is x is equal to 0. So we will consider two cases, when x is greater than 0 and when x is less than 0. When x is greater than 0, mod x is equal to plus x. And when x is less than 0, mod x is equal to minus x. Case 1, when x is greater than 0. So x square plus 5 mod x plus 4 is equal to 0 will be written as x square plus 5x plus 4 is equal to 0. Its roots are given by minus b plus minus under root b square minus 4ac upon 2a. So the roots are minus 1 and minus 4. Since x is greater than 0, so both the roots are rejected. Case 2, when x is less than 0. So mod x is equal to minus x. So the quadratic equation will be x square minus 5x plus 4 is equal to 0. Its roots are given by minus b plus minus under root b square minus 4ac upon 2a. So the roots are 4 and 1. But x is less than 0. So both the roots are rejected. So finally, number of real roots of the given equation is 0. So the answer is 0. Fourth question, the number of real solutions of mod 2x minus x square minus 3 is equal to 1 is. These are the options given. The given equation is mod 2x minus x square minus 3 is equal to 1. This can be interpreted as whether this is positive or negative. Its value is 1. So we can write two equations. When this is positive, that is equal to 1, and when this is negative, that is also equal to 1. From equation 1, we get two roots as 1 plus minus root 3i. So both are complex roots. That means no real solutions from this equation. From equation number 2, we get two roots as 1 plus minus I. Again, both roots are complex. So no real solutions from this equation as well. So finally, number of real solutions are 0. So the correct option is option A. Fifth question, the value of a such that x square minus 11x plus a is equal to 0 and x square minus 14x plus 2a is equal to 0 may have a common root is. These are the options given. Suppose alpha is common root in both the equations. So it will satisfy both the equations. We can write alpha square minus 11 alpha plus a is equal to 0 and alpha square minus 14 alpha plus 2a is equal to 0. Solving both the equations, we get alpha is equal to a by 3. Put the value of alpha in first equation. So we get value of a as either 0 or 24. If the value of a is 0, then x square minus 11x plus 0 is equal to 0 and x square minus 14x plus 0 is equal to 0. That means x square minus 11x is equal to x square minus 14x, which gives x is equal to 0, which is not correct. So a is equal to 0 is rejected. So finally, a is equal to 24. So the correct option is option C. Sixth question, the value of under root 6 plus under root 6 plus under root 6 plus and so on up to infinity is. Suppose x is equal to under root 6 plus under root 6 plus under root 6 plus and so on up to infinity. So this can be written as x is equal to under root 6 plus. This whole part can be replaced by x because infinity minus 1 is also equal to infinity. So x is equal to under root 6 plus x. Now square both the sides. So it is x square is equal to 6 plus x or x square minus x minus 6 is equal to 0. This can be factorized as x plus 2 into x minus 3. So x is either equal to minus 2 or plus 3. X is equal to minus 2 is rejected because the square root of a real number is always positive. So x is equal to 3 is the final answer. So we will fill 3 here. Seventh question, if alpha beta are the roots of the equation x square plus px plus 1 is equal to 0, gamma delta are the roots of the equation x square plus qx plus 1 is equal to 0, then alpha minus gamma into alpha plus delta into beta minus gamma into beta plus delta is equal to. It is given that alpha and beta are the roots of equation x square plus px plus 1 is equal to 0. So alpha plus beta is equal to minus p and alpha beta is equal to 1. Suppose this is equation number 1 and this is equation number 2. Similarly, gamma and delta are the roots of equation x square plus qx plus 1 is equal to 0. So gamma plus delta is equal to minus q and gamma delta is equal to 1. Suppose this is equation number 3 and this is equation number 4. We have to get the value of alpha minus gamma into alpha plus delta into beta minus gamma into beta plus delta. We will multiply these two together and these two together. When we multiply these two together, we get alpha square minus gamma delta plus alpha delta minus alpha gamma. When we multiply these two together, we get beta square minus gamma delta plus beta delta minus beta gamma. Value of gamma delta is equal to 1. So we will put 1 here. So we get alpha square minus 1 plus alpha into delta minus gamma. And here we get beta square minus 1 plus beta into delta minus gamma. Now we will multiply these two together. So when alpha square minus 1 is multiplied with beta square minus 1, we get the first term as alpha square minus 1 into beta square minus 1. When alpha into delta minus gamma is multiplied with beta into delta minus gamma, we get alpha beta into delta minus gamma whole square as second term. When we multiply alpha square minus 1 with beta into delta minus gamma, we get the third term as alpha square minus 1 into beta into delta minus gamma. And when we multiply beta square minus 1 with alpha into delta minus gamma, we get the fourth term as beta square minus 1 into alpha into delta minus gamma. We will solve first term, second term and third and fourth combined. So from first term we get 4 minus p square. From second term we get q square minus 4. And from third and fourth combined we get 0. So our desired answer is this plus this, and that is q square minus p square. So we will fill q square minus p square here. Last question, if alpha beta are roots of the equation x square plus x plus 1 is equal to 0, then the equation whose roots are alpha to power 19 and beta to power 7 is. Given that alpha beta are roots of the equation x square plus x plus 1 is equal to 0. So roots are given by minus b plus minus under root b square minus 4ac upon 2a. So roots come out to be minus 1 plus minus root 3i by 2. Suppose alpha is equal to minus 1 by 2 plus root 3i by 2. So beta is equal to minus 1 by 2 minus root 3i by 2. Alpha can be written as cos 2 pi by 3 plus I sin 2 pi by 3 and beta can be written as cos 2 pi by 3 minus I sin 2 pi by 3. We have to find the quadratic equation whose roots are alpha to power 19 and beta to power 7. First, we will simplify them. So alpha to power 19 is equal to cos 2 pi by 3 plus I sin 2 pi by 3 to the power 19. Applying the Myers theorem, power will be multiplied with the angles. So it will be cos 38 pi by 3 plus I sin 38 pi by 3. 38 pi by 3 can be written as 2 pi into 6 plus 2 pi by 3. Now this is in the form 2 n pi plus theta, which will be equal to theta. So this can be written as cos 2 pi by 3 plus I sin 2 pi by 3. And this is equal to alpha. So alpha to power 19 is equal to alpha. Let us simplify beta to power 7. So beta to power 7 is equal to cos 2 pi by 3 minus I sin 2 pi by 3 to the power 7. Now applying the Myers theorem, it will be cos 14 pi by 3 minus I sin 14 pi by 3. Power will be multiplied with the angles. 14 pi by 3 can be written as 2 pi into 2 plus 2 pi by 3. This is in the form 2 n pi plus theta, which is equal to theta. So this can be written as cos 2 pi by 3 minus I sin 2 pi by 3, which is equal to beta. So beta to power 7 is equal to beta. So we have got the result as alpha to power 19 is equal to alpha and beta to power 7 is equal to beta. So the quadratic equation whose roots are alpha to power 19 and beta to power 7 will be same as whose roots are alpha and beta. So this is the required quadratic equation. So our answer will be x square plus x plus 1 is equal to 0. Now let us see the graphs of a quadratic expression in different conditions. Suppose y is equal to ax square plus bx plus c, where a, b, c are real and a is not equal to 0. Then the graph between x and y is a parabola. In figure 1, 2 and 3, a is greater than 0 and the parabola is called concave upwards. Its mouth is open upwards. In figure 4, 5 and 6, a is less than 0 and the parabola is called concave downwards. Its mouth is open downwards. Alpha and beta are two roots of the quadratic equation ax square plus bx plus c is equal to 0. Point P is called apex of the parabola. It is given by the coordinates minus b by 2a, comma, minus d by 4a, where d is discriminant. In figure 1 and 4, d is greater than 0. That means roots are real and distinct. Above the x-axis, y is positive and y is equal to ax square plus bx plus c. That represents this curve. In figure 1, curve is positive when x lies between minus infinity to alpha and beta to plus infinity. And curve is negative when x lies between alpha to beta. In figure 4, curve is positive when x lies between alpha to beta and curve is negative when x lies between minus infinity to alpha and beta to plus infinity. In figure 2 and 5, d is equal to 0. That means roots are real and coincident. In figure 2, ax square plus bx plus c is greater than 0 for all x except when x is equal to alpha or x is equal to beta. And ax square plus bx plus c is equal to 0 when x is equal to alpha or x is equal to beta. In figure 5, ax square plus bx plus c is less than 0 for all x except when x is equal to alpha or x is equal to beta. And ax square plus bx plus c is equal to 0 when x is equal to alpha or x is equal to beta. In figure 3 and 6, d is less than 0. Curve neither touches nor crosses the x-axis. So roots are imaginary or complex conjugate. In figure 3, ax square plus bx plus c is greater than 0 for all x. And in figure 6, ax square plus bx plus c is less than 0 for all x. Maximum and minimum values of a quadratic expression. Suppose y is equal to ax square plus bx plus c. When a is greater than 0, this curve represents y is equal to ax square plus bx plus c. Y minimum will occur at the vertex and y minimum will be equal to minus d by 4a. When a is less than 0, this curve will represent y is equal to ax square plus bx plus c. Y max will occur at vertex and its value is minus d by 4a. So y max is equal to minus d by 4a. Let us solve 4 questions based on what we have learned so far. First question, find the minimum value of the expression 2x square plus x minus 1. There are two methods to solve this question. First method is related to quadratic expressions and second method is related to maxima and minima. First method, the given expression is in the form ax square plus bx plus c. So comparing, we get a is equal to 2, b is equal to 1 and c is equal to minus 1. Discriminant d is equal to b square minus 4ac. So d comes out to be equal to 9. A is greater than 0 and d is greater than 0. So graph of 2x square plus x minus 1 will be something like this. Y minimum will occur at point P, which is apex of the parabola. Its value is given by minus d by 4a. So y minimum is equal to minus d by 4a, which comes out to be equal to minus 9 by 8. Second method. Suppose a is equal to the given expression 2x square plus x minus 1. Condition for minima is dA upon dx is equal to 0 and d square a upon dx square is greater than 0. So dA by dx comes out to be equal to 4x plus 1. We will equate this to 0. So x is equal to minus 1 by 4. Next, we will confirm that at x is equal to minus 1 by 4, minima occurs. And that can be confirmed from here, d square a upon dx square. So d square a upon dx square is equal to 4. 4 is greater than 0. That means at x is equal to minus 1 by 4, minima will occur. Put x is equal to minus 1 by 4 here. So a minimum is equal to minus 9 by 8. Second question, if y is equal to x square minus 2x minus 3, then find the range of y when x is real, when x lies between 0 and 3, and when x lies between minus 2 and 0. We can solve this question easily by drawing the graph. First, compare the given expression with ax square plus bx plus c. So a is equal to 1, b is equal to minus 2, and c is equal to minus 3. Discriminant d is equal to b square minus 4ac, and that is equal to 16. Here a is greater than 0 and d is also greater than 0. So graph of the given expression will be something like this. Apex of the parabola will be at minus b by 2a comma minus d by 4a. Minus b by 2a is equal to 1 and minus d by 4a is equal to minus 4. So the apex will be at 1 comma minus 4. This is shown by point P. First part, when x is real. When x is real, it can take any value on the number line. So we need to consider all the points on this parabola to get y minimum and y maximum. Quite clearly, y minimum is minus 4 and y maximum will occur at infinity. So y minimum is minus 4 and y max is plus infinity in this case. So range of y is between minus 4 and infinity. Second part, when x lies between 0 and 3. When x lies between 0 and 3, we need to consider this part of the curve between C and B. So y minimum will again be minus 4 and y maximum will occur at point B and its maximum value is 0. So y minimum is minus 4 and y max is 0 in this case. So range of y is minus 4 comma 0. Third part, when x lies between minus 2 and 0. When x lies between minus 2 and 0, we need to consider this part of the curve between E and C. Quite clearly, y minimum will occur at C when x is 0 and y max will occur at E when x is equal to minus 2. So put x is equal to 0 here to get y minimum. So y minimum is equal to minus 3 and put x is equal to minus 2 here to get y max. So y max is equal to 5. So range of y in this case will be minus 3 comma 5. Third question, if a, b, c are real, then in y is equal to ax square plus bx plus c, comment on the sign of a, d, alpha plus beta and alpha beta. Here alpha and beta are roots of the given quadratic equation. By just observing the given graph, we can say that a is less than 0 and d is greater than 0. So part 1 is a is less than 0 and part 2 is d is greater than 0. Third part, sign of alpha plus beta. Here both the roots alpha and beta are negative, so their addition will be negative. That means alpha plus beta is less than 0. Sign of alpha beta. Since both the roots are negative, so their product will be positive. So we can say that alpha beta is greater than 0. Last question, find the range of the expression 4 into 2x minus 1 upon x plus 1 whole square minus 2, where x is real. To solve such questions, suppose y is equal to the given expression. So y is equal to 8x minus 4 upon x square plus 2x minus 1. Cross multiply to get a quadratic equation in x, and that is yx square plus 2y minus 8 into x plus 4 minus y is equal to 0. Given that x is real, so discriminant d is greater than or equal to 0. Compare this equation with ax square plus bx plus c is equal to 0. So a is equal to y, b is equal to 2y minus 8 and c is equal to 4 minus y. So discriminant d is equal to b square minus 4ac, and that is 2y minus 8 whole square minus 4y into 4 minus y. Since d is greater than or equal to 0, so the inequality is 2y minus 8 whole square minus 4y into 4 minus y is greater than or equal to 0. After simplification, this inequality is 8 into y minus 2 into y minus 4 is greater than or equal to 0. Critical points will be at y is equal to 2 and at y is equal to 4. Now draw a number line, mark points 2 and 4. Draw a wavy curve starting from top right and passing through 4 and 2. Inequality is greater than or equal to 0. So we need to consider the zone which is above the number line. So y lies between minus infinity to 2 and 4 to plus infinity. And that is the range of the given expression. Let us understand location of roots in a quadratic equation ax square plus bx plus c is equal to 0, where a, b, c are real and a is not equal to 0. We will consider 6 scenarios and write the corresponding conditions. Here it is assumed that a is greater than 0. If a is less than 0, then we need to divide both sides of the equation by a, so that coefficient of x square is 1, which is greater than 0. Then we can apply all these conditions. Scenario 1. When both roots are greater than a specified number. Suppose the specified number is d and roots are alpha and beta. Then alpha and beta both are greater than d. Conditions applicable in this scenario are d is greater than 0 or d is equal to 0. Fd is greater than 0 and minus b by 2a is greater than d. Let us understand them one by one. D is greater than 0 means roots are real and distinct. D is equal to 0 means roots are real and coincident. To understand Fd is greater than 0, draw a perpendicular on x-axis passing through D. Suppose this perpendicular line intersects the curve at P. So perpendicular distance from P to x-axis is called Fd. Above the x-axis is considered positive and below the x-axis is considered negative. So in this case, Fd is greater than 0. Minus b by 2a is x-coordinate of the vertex of the parabola. Point Q represents x is equal to minus b by 2a, which is greater than d. So this is third condition. So these three conditions are applicable in this scenario. Scenario 2. When both roots are less than a specified number. Suppose the specified number is d and the roots are alpha and beta. So alpha and beta both are less than d. Three conditions applicable in this scenario are d is greater than or equal to 0, fd is greater than 0 and minus b by 2a is less than d. Let us understand them one by one. D is greater than 0 means roots are real and distinct. D is equal to 0 means roots are real and coincident. Clearly, Fd is greater than 0. Point Q represents x is equal to minus b by 2a. So, minus b by 2a is less than d. And this is condition number 3. So, these three conditions are applicable in this scenario. Scenario 3. When both roots lie on either side of a specified number. Suppose the specified number is d. So d lies between roots alpha and beta. So Fd is less than 0 is the only condition in this scenario. Scenario 4. When exactly one root lie in the given interval d, e. Suppose this is the given interval. Root alpha lies in this interval. So FD is positive and FE is negative. Their product will be negative. So FD into FE is less than 0. Suppose root beta lies in this interval. So in this case, FD is negative and FE is positive. Again, their product will be negative. So FD into FE is less than 0 is the only condition in this scenario. Scenario 5. When both the roots lie in the given interval d, e. Suppose this is the given interval and the roots are alpha and beta. So both the roots alpha and beta lie in the given interval. There are 4 conditions applicable in this scenario. Let us understand them one by one. When d is greater than 0, roots are real and distinct. When d is equal to 0, roots are real and coincident. FD is greater than 0. FE is greater than 0. And minus b by 2a lies between d and e. Point Q represents x is equal to minus b by 2a. Point Q is between d and e. So minus b by 2a lies between d and e, which is the 4th condition. So these 4 conditions are applicable in this scenario. Scenario 6. When both roots are out of a given interval d, e. Suppose this is the given interval and roots are alpha and beta. So alpha and beta both are out of the given interval. So there are 2 conditions applicable in this scenario. FD is less than 0 and FE is less than 0. There is no need to memorize the conditions scenario wise. Just draw the graph and mark those points and roots. Then you can write the conditions on your own. Now let us see 3 JEE questions based on what we have learned so far. First question, the values of a for which one root of the equation x square minus a plus 1 into x plus a square plus a minus 8 is equal to 0 exceeds 2 and the other is lesser than 2 are given by. These are the options given. This question was asked in JEE Mains 2013. Suppose 2 roots of the given quadratic equation are alpha and beta. It is given that one root is more than 2 and the other root is less than 2. F2 will be represented by a point P on this curve between alpha and beta. So quite clearly F2 will be negative. So F2 is less than 0. Put x is equal to 2 in this expression to get F2. So the inequality we get is a plus 2 into a minus 3 is less than 0. Critical points are minus 2 and plus 3. Draw a number line and mark points 3 and minus 2. Draw a wavy curve starting from top right and passing through 3 and minus 2. Inequality is less than 0. So we need to consider the zone below the number line. So A lies between minus 2 to plus 3. So the correct option is option A. Second question, if both the roots of the quadratic equation x square minus mx plus 4 is equal to 0 are real and distinct and they lie in the interval 1, 5, then m lies in the interval. These are the options given. This question was asked in JEE Mains 2019. First we will draw the graph. Suppose this curve represents y is equal to x square minus mx plus 4. Given that roots are real and distinct. Suppose roots are alpha and beta. It is also given that they lie in the interval 1, 5. Suppose this is point 1 and this is point 5. So roots alpha and beta lie between 1 and 5. Now we will write the conditions. Condition number 1. Roots are real and distinct. So d is greater than 0. For condition number 2 and 3. Point P on the curve represents F1. So quite clearly F1 is positive. Point Q on the curve represents F5. So again F5 is positive. Minus b by 2a, which is x coordinate of the vertex, lies between 1 and 5. So this is condition number 4. We will apply all the conditions one by one. Compare the given quadratic equation x square minus mx plus 4 is equal to 0 with ax square plus bx plus c is equal to 0. So a is equal to 1, b is equal to minus m and c is equal to 4. Discriminant d is equal to b square minus 4ac. So d is equal to m square minus 16. Condition 1 says d is greater than 0. So m square minus 16 is greater than 0, or m minus 4 into m plus 4 is greater than 0. Critical points are plus 4 and minus 4. Draw a number line and mark the points minus 4 and 4. Draw a wavy curve starting from top right and passing through plus 4 and minus 4. Inequality is greater than 0. So we will consider the zone above the number line. So m lies between minus infinity to minus 4 and 4 to infinity. Condition number 2 says fd is greater than 0. Here d is equal to 1. So f1 is greater than 0. Put x is equal to 1 in this expression to get f1. So the condition is m is less than 5. Condition number 3 says fe is greater than 0. Here e is equal to 5. So f5 is greater than 0. Put x is equal to 5 in this expression to get f5. So the condition is m is less than 5 whole 4 by 5. Condition number 4. Minus b by 2a lies between 1 and 5. So m by 2 lies between 1 and 5, or m lies between 2 and 10. Condition number 2 says m is less than 5. Condition number 3 says m is less than 5 whole 4 by 5. And condition number 4 says m is less than 10. So we can combine conditions 2, 3 and 4 and say that m is less than 5. Condition number 1 says m is greater than 4. So m lies between 4 and 5. So that is our answer. So the correct option is option A. Last question. Consider the quadratic equation c minus 5 into x square minus 2cx plus c minus 4 is equal to 0. C is not equal to 5. Let S be the set of all integral values of C for which one root of the equation lies in the interval 0, 2 and its other root lies in the interval 2, 3. Then the number of elements in S is. These are the options given. This question was asked in JEE Mains 2019. First, we will draw the graph. Suppose this curve represents y is equal to c minus 5 into x square minus 2cx plus c minus 4. Its roots are alpha and beta. It is given that one root lies between 0 and 2 and the other root lies between 2 and 3. Suppose alpha lies between 0 and 2 and beta lies between 2 and 3. We will assume here that coefficient of x square is positive so that we can apply all the conditions we know. So c minus 5 is greater than 0 or c is greater than 5. This is point number 1. From the graph it is clear that f2 is negative, f0 is positive and f3 is also positive. So these will be our condition number 2, 3 and 4. Condition number 2, f2 is less than 0. Put x is equal to 2 in this expression to get f2. So the condition is c is less than 24. This is point number 2. Condition number 3, f0 is greater than 0. Put x is equal to 0 in this expression to get f0. So c is greater than 4. This is point number 3. Condition number 4, f3 is greater than 0. Put x is equal to 3 in this expression to get f3. So the condition is c is greater than 12 whole 1 by 4. This is point number 4. From point number 1, 3 and 4, we can say that c is greater than 12 whole 1 by 4. From point number 2, c is less than 24. So combining all the points 1, 2, 3 and 4, we can say that c lies between 12 whole 1 by 4 and 24. So integral values between 12 whole 1 by 4 and 24 will be 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 and 23. So they are 11 in number. So our correct option is A. Let us talk about theory of equations. To get the roots of higher order equations, for example, cubic equations, biquadratic equations, and so on, we need to know theory of equations. Even the roots of a quadratic equations are derived from theory of equations. Suppose alpha 1, alpha 2, alpha 3, and so on up to alpha n are roots of the equation a0 x to power n plus a1 x to power n minus 1 plus a2 x to power n minus 2 plus and so on up to an minus 1 x plus an is equal to 0, where a0, a1, a2 and so on up to an are constants and a0 is not equal to 0. Then we can write a0 x to power n plus a1 x to power n minus 1 plus a2 x to power n minus 2 plus and so on up to an minus 1 x plus an is equal to a0 into x minus alpha 1 into x minus alpha 2 and so on up to x minus alpha n. Now we can compare coefficients of like powers of x and say that S1 is equal to summation of alpha I, means sum of the roots taken one at a time, and that is equal to minus a1 upon a0. S2 is equal to sum of the roots taken 2 at a time, and that is equal to minus 1 to power 2 a2 upon a0. S3 is equal to sum of the roots taken 3 at a time, and that is equal to minus 1 to power 3 a3 upon a0. Similarly, Sn is equal to sum of the roots taken n at a time, and that is equal to alpha 1, alpha 2, alpha 3 and so on up to alpha n, and that is equal to minus 1 to power n an upon a0. We will apply these rules to find out the roots of a quadratic equation and a cubic equation. Suppose alpha and beta are roots of the equation ax square plus bx plus c is equal to 0. Then alpha plus beta is equal to sum of the roots taken one at a time, and that is equal to minus a1 by a0, and that is equal to minus b by a. Alpha beta is sum of the roots taken 2 at a time, and that is equal to minus 1 to power 2 a2 upon a0, and that is equal to c upon a. Roots of a cubic equation. Suppose alpha, beta and gamma are the roots of the cubic equation ax cube plus bx square plus cx plus d is equal to 0. Then alpha plus beta plus gamma is sum of the roots taken one at a time, and that is equal to minus b upon a. Alpha beta plus beta gamma plus gamma alpha is sum of the roots taken 2 at a time, and that is equal to minus 1 to power 2 a2 upon a0, and that is equal to c by a. Alpha beta gamma is sum of the roots taken 3 at a time, and that is equal to minus 1 to power 3 a3 upon a0. So it is minus d upon a. Now let us understand transformation of an equation method with the help of one question. If the roots of ax square plus bx plus c is equal to 0 are alpha and beta, then find the equation whose roots are alpha square and beta square. It is given that roots of ax square plus bx plus c is equal to 0 are alpha and beta. So we can write alpha plus beta is equal to minus b by a and alpha beta is equal to c by a. We have to find the equation whose roots are alpha square and beta square. So first step of the transformation of an equation method is suppose y is equal to alpha square. So alpha is equal to under root y. Since alpha is one root of ax square plus bx plus c is equal to 0, so x is equal to alpha will satisfy this equation. That means a alpha square plus b alpha plus c is equal to 0. Put the value of alpha from here. So the equation will be a under root y whole square plus b under root y plus c is equal to 0, or ay plus b under root y plus c is equal to 0, or ay plus c is equal to minus b under root y. Now square both sides of this equation. So ay plus c whole square is equal to minus b root y whole square. So the equation is a square y square plus 2ac minus b square into y plus c square is equal to 0. Put x in place of y. So the required equation is a square x square plus 2ac minus b square into x plus c square is equal to 0. Let us see a couple of questions based on what we have learned so far. First question, if alpha, beta and gamma be the roots of ax cube plus bx square plus cx plus d is equal to 0, then find the value of part A, summation alpha square, and part B, summation alpha square into beta plus gamma. It is given that alpha, beta and gamma are roots of ax cube plus bx square plus cx plus d is equal to 0. So from theory of equations, we can write that alpha plus beta plus gamma is equal to minus b by a, alpha beta plus beta gamma plus gamma alpha is equal to c by a, and alpha beta gamma is equal to minus d by a. Part A. Summation alpha square means alpha square plus beta square plus gamma square. This can be written as alpha plus beta plus gamma whole square minus 2 into alpha beta plus beta gamma plus gamma alpha. Value of alpha plus beta plus gamma we will put from equation number 1. And value of alpha beta plus beta gamma plus gamma alpha we will put from equation number 2. So summation of alpha square is equal to b square minus 2ac upon a square. Part B. Summation of alpha square into beta plus gamma means alpha square into beta plus gamma plus beta square into alpha plus gamma plus gamma square into alpha plus beta. We can write first term as alpha square into alpha plus beta plus gamma minus alpha cube. Similarly, we can write second term as beta square into alpha plus beta plus gamma minus beta cube. And third term can be written as gamma square into alpha plus beta plus gamma minus gamma cube. Now we will take alpha plus beta plus gamma common in all three terms. So summation of alpha square into beta plus gamma is equal to alpha plus beta plus gamma into alpha square plus beta square plus gamma square minus alpha cube plus beta cube plus gamma cube. For this, we will use identity a cube plus b cube plus c cube minus 3abc is equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. In place of a, b and c, we will put alpha, beta and gamma. So summation of alpha square into beta plus gamma is equal to 3ad minus bc upon a square. Second question, if alpha and beta are roots of ax square plus bx plus c is equal to 0, then find the equation whose roots are. Part A, 1 by a alpha plus b and 1 by a beta plus b. Part B, alpha plus 1 by beta and beta plus 1 by alpha. It is given that alpha and beta are roots of ax square plus bx plus c is equal to 0. So we can write alpha plus beta is equal to minus b by a and alpha beta is equal to c by a. Part A. We will apply transformation of an equation method here. Suppose y is equal to 1 by a alpha plus b. So alpha is equal to 1 minus by upon ay. Since alpha is one root of the equation ax square plus bx plus c is equal to 0, so x is equal to alpha will satisfy this equation. So a alpha square plus b alpha plus c is equal to 0. Put the value of alpha from here. So the equation is a into 1 minus by upon ay whole square plus b into 1 minus by upon ay plus c is equal to 0. So after simplification, the equation is acy square minus by plus 1 is equal to 0. Put x in place of y. So the required equation is acx square minus bx plus 1 is equal to 0. Part B. We cannot apply transformation of an equation method here because if we put y is equal to alpha plus 1 by beta, we cannot write alpha in terms of y because beta will also be there. So we will change our approach here. Equation whose roots are alpha plus 1 by beta and beta plus 1 by alpha will be given by x minus first root into x minus second root is equal to 0. In place of first root, put alpha plus 1 by beta, and in place of second root, put beta plus 1 by alpha, and simplify. So the required equation is acx square plus b into a plus c into x plus a plus c whole square is equal to 0. Let us solve previous year's JEE questions. First question, the sum of solutions of the equation mod root x minus 2 plus root x into root x minus 4 plus 2 is equal to 0, where x is greater than 0 is equal to. These are the options given. This question was asked in JEE Mains 2019. The given equation is mod root x minus 2 plus root x into root x minus 4 plus 2 is equal to 0. Put root x is equal to t so that the calculation is easier. So the equation will be mod t minus 2 plus t into t minus 4 plus 2 is equal to 0. Critical point is t is equal to 2. So we will consider two cases, when t is greater than 2 and when t is less than 2. Case 1, when t is greater than 2. When t is greater than 2, mod t minus 2 will be written as plus t minus 2. So the equation will be t minus 2 plus t into t minus 4 plus 2 is equal to 0, or t into t minus 3 is equal to 0. So t is equal to 0 or t is equal to 3. Since t is greater than 2, so t is equal to 0 is rejected. So the solution in this case will be t is equal to 3. T is equal to root x. So root x is equal to 3. Square both the sides. So x is equal to 9. This is the solution in this case. Case 2. When t is less than 2. When t is less than 2, mod t minus 2 will be written as minus t minus 2. So the equation will be minus t minus 2 plus t into t minus 4 plus 2 is equal to 0, or t minus 1 into t minus 4 is equal to 0. So t is equal to 1 or t is equal to 4. Since t is less than 2, so t is equal to 4 is rejected. So solution in this case is t is equal to 1. T is equal to root x. So root x is equal to 1. Square both the sides. So x is equal to 1. So we have got two solutions. X is equal to 9 and x is equal to 1. So sum of solutions will be 9 plus 1, and that is 10. So the option C is correct. Second question, let S be the set of all real roots of the equation 3 to power x into 3 to power x minus 1 plus 2 is equal to mod 3 to power x minus 1 plus mod 3 to power x minus 2. Then S is. These are the options given. This question was asked in JEE Mains 2020. The given equation is 3 to power x into 3 to power x minus 1 plus 2 is equal to mod 3 to power x minus 1 plus mod 3 to power x minus 2. Put 3 to power x is equal to t so that calculation is easier. So the equation will be t into t minus 1 plus 2 is equal to mod t minus 1 plus mod t minus 2. Critical points are t is equal to 1 and t is equal to 2. So we will consider three cases. When t is less than 1, when t lies between 1 and 2, and when t is greater than 2. Case 1. When t is less than 1. When t is less than 1, both mod t minus 1 and mod t minus 2 will be negative. So the equation will be t into t minus 1 plus 2 is equal to minus t minus 1 minus t minus 2. So t is equal to minus 1 plus root 5 by 2 and t is equal to minus 1 minus root 5 by 2. This will give positive value of t and this will give negative value of t. T is equal to 3 to power x, and 3 to power x will always be positive whether x is positive or negative. So its value cannot be negative. So this solution is rejected. We will get only one solution here. Case 2. When t lies between 1 and 2. When t lies between 1 and 2, mod t minus 1 will be positive and mod t minus 2 will be negative. So equation in this case will be t into t minus 1 plus 2 is equal to t minus 1 minus t minus 2, or t is equal to 1 plus minus root 3i by 2. Both the roots will be complex, so no real solution in this case. Case 3, when t is greater than 2. When t is greater than 2, both mod t minus 1 and mod t minus 2 will be positive. So the equation will be t into t minus 1 plus 2 is equal to t minus 1 plus t minus 2. So t is equal to 3 plus minus root 11i by 2. So again, both the roots will be complex. So no real solution in this case as well. So finally, we will get only one solution from here. So set S will have only one element. So it is a singleton set. So option D is correct. Third question, the number of real roots of the equation e to power 4x plus e to power 3x minus 4 into e to power 2x plus e to power x plus 1 is equal to 0 is. These are the options given. This question was asked in JEE Mains 2020. The given equation is e to power 4x plus e to power 3x minus 4 into e to power 2x plus e to power x plus 1 is equal to 0. This can be written as e to power x to power 4 plus e to power x to power 3 minus 4 into e to power x to power 2 plus e to power x plus 1 is equal to 0. Put e to power x is equal to t so that calculation will be easier. So this equation becomes t to power 4 plus t cube minus 4t square plus t plus 1 is equal to 0. Now put t is equal to 1 to check whether t is equal to 1 is one solution of this equation or not. We get LHS is equal to RHS. That means t is equal to 1 is one solution of this equation. Or we can say t minus 1 is one factor of this expression. We can get other factors by following two methods. Method 1. Divide this expression by t minus 1. So we get t cube plus 2t square minus 2t minus 1 as other factors. Method number 2. We can write this expression as t to power 4 minus t cube plus 2t cube minus 2t square minus 2t square plus 2t minus t plus 1. So that we can take t minus 1 common in consecutive pair of terms starting from left hand side. So in term 1 and 2, if we take t cube common, we get t minus 1 in bracket. In term 3 and 4, if we take 2t square common, we get t minus 1 in bracket. In term 5 and 6, if we take minus 2t common, we get t minus 1 in bracket. In term 7 and 8, if we take minus 1 common, then we get t minus 1 in bracket. Now in these four terms, we can take t minus 1 common. So we get t minus 1 into t cube plus 2t square minus 2t minus 1. So we have factorized this expression as this. Now this equation means either t minus 1 is 0 or t cube plus 2t square minus 2t minus 1 is 0. Now we can factorize this expression following the same method starting from here. So this will be factorized as t minus 1 into t square plus 3t plus 1. So this expression is factorized as t minus 1 into t minus 1 into t square plus 3t plus 1. Now we can easily get roots of this equation t square plus 3t plus 1 is equal to 0. So the roots will be t is equal to minus 3 plus root 5 by 2 and minus 3 minus root 5 by 2. Value of t will be negative here and value of t will be negative here as well. So both roots are negative. T is equal to e to power x and e to power x will always be positive whether x is positive or negative. So both the roots being negative will be rejected. So finally we have got only one root and that is t is equal to 1. T is equal to e to power x. So e to power x is equal to 1. 1 can be written as e to power 0. On both the sides, base is same and that is e. So we can equate exponents. So x is equal to 0. So x is equal to 0 is the only real root of this equation. So our answer is D. Fourth question, the probability of selecting integers a that belong to interval minus 5 to 30 such that x square plus 2 into a plus 4 into x minus 5a plus 64 is greater than 0 for all x that is real is. These are the options given. This question was asked in JEE Mains 2021. Recall this graph. We know that if the sign of expression ax square plus bx plus c is positive for all x that is real, that means a is greater than 0 and d is less than 0. Here a is coefficient of x square and d is discriminant. Coefficient of x square is 1 and 1 is greater than 0. So a is greater than 0. Now we will form this inequality, d is less than 0. Compare the given expression with ax square plus bx plus c. So we get a is equal to 1, b is equal to 2 into a plus 4 and c is equal to minus 5a plus 64. So discriminant d is equal to b square minus 4ac. So d is simplified as 4 into a plus 16 into a minus 3. D is less than 0. So the inequality is 4 into a plus 16 into a minus 3 is less than 0. Critical points are minus 16 and plus 3. To solve this inequality, draw a number line and mark the points 3 and minus 16. Draw a wavy curve starting from top right and passing through 3 and minus 16. Inequality is less than 0. So we need to consider the zone below the number line. So a lies between minus 16 to plus 3. So all the possible values of a can be minus 15, minus 14, minus 13 and so on up to plus 2. Suppose this is point number 1. It is given that a belongs to the interval minus 5 to plus 30. So as per this interval, possible values of a can be minus 5, minus 4, minus 3 and so on up to plus 30. Suppose this is point number 2. Now we will take common from point number 1 and point number 2 to say that all the possible values of a will be minus 5, minus 4, minus 3 and so on up to plus 2. They are 8 in number. Total possible values of a in this interval will be 36. Count minus 5, minus 4, minus 3 and so on up to plus 30. So they will be 36 in number. So the probability will be number of possible outcomes of a upon total number of outcomes of a, and that is 8 upon 36. So it will be 2 upon 9. So our option will be option B is correct. Fifth question, the number of all possible positive integral values of alpha for which the roots of the quadratic equation 6x square minus 11x plus alpha is equal to 0 are rational numbers is. These are the options given. This question was asked in JEE Mains 2019. The given quadratic equation is 6x square minus 11x plus alpha is equal to 0. So we can find its roots by the formula x is equal to minus b plus minus under root b square minus 4ac upon 2a. So the roots are 11 plus minus under root 121 minus 24 alpha upon 12. It is given that roots are rational numbers. That means this under root sign should not be there. Or in other words, 121 minus 24 alpha should be perfect square. It is also given that alpha can take positive integral values. So we will put values of alpha as 1, 2, 3 and so on to see for which values of alpha 121 minus 24 alpha is perfect square. So let us start putting the values of alpha as 1, 2, 3 and so on. When alpha is equal to 1, value of 121 minus 24 alpha is 97 and 97 is not a perfect square. When alpha is equal to 2, value of 121 minus 24 alpha is 73, which is not a perfect square. When alpha is 3, value of 121 minus 24 alpha is 49, which is perfect square of 7. When alpha is 4, value of 121 minus 24 alpha is 25, which is perfect square of 5. When alpha is equal to 5, value of 121 minus 24 alpha is 1, which is perfect square of 1. We have to stop here. Because when we put alpha is equal to 6, value of 121 minus 24 alpha will be negative. So the roots will be complex conjugate. But it is given that roots are rational numbers. So we have found the values of alpha as 3, 4 and 5, for which 121 minus 24 alpha will be perfect square. So number of values of alpha will be 1, 2 and 3. So the number of all possible positive integral values of alpha will be 3. So option C is correct. Sixth question, let alpha is equal to maximum of 8 to power 2 sine 3x into 4 to power 4 cos 3x where x is real. And beta is equal to minimum of 8 to power 2 sine 3x into 4 to power 4 cos 3x where x is real. If 8x square plus bx plus c is equal to 0 is a quadratic equation whose roots are alpha to power 1 by 5 and beta to power 1 by 5, then the value of c minus b is equal to. These are the options given. This question was asked in JEE Mains 2021. It is given that alpha is equal to maximum of this. First, we will simplify this part. 8 can be written as 2 to power 3 and 4 can be written as 2 to power 2. Now powers will be multiplied. So this part will be 2 to power 6 sine 3x and this part will be 2 to power 8 cos 3x. Now bases are same, so powers will be added up. So this can be written as 2 to power 6 sine 3x plus 8 cos 3x. Now this will be maximum when power is maximum and this will be minimum when power is minimum. So suppose power is equal to A. So at maxima or minima, dA upon dx is equal to 0. So this gives tan 3x is equal to 3 by 4. Make a right angle triangle to figure out sin 3x and cos 3x. So sin 3x is equal to 3 by 5 and cos 3x is equal to 4 by 5. Tan theta is positive in first and third quadrants. So A will be maximum in first quadrant where sin theta and cos theta both will be positive. And A will be minimum in third quadrant where sin theta and cos theta both will be negative. So let us find out maximum and minimum values of A. So A maximum will be equal to 6 into sin 3x, that is plus 3 by 5, plus 8 into cos 3x, and that is plus 4 by 5. So A maximum will be equal to 10. So alpha is equal to 2 to power 10. Similarly, we will calculate A minimum when sin theta and cos theta both will be negative. So A minimum is equal to 6 into minus 3 by 5 plus 8 into minus 4 by 5. So A minimum is equal to minus 10. So beta is equal to 2 to power minus 10. We have got the values of alpha and beta. So alpha to power 1 by 5 is equal to 4 and beta to power 1 by 5 is equal to 1 by 4. We have got alpha to power 1 by 5 equal to 4 and beta to power 1 by 5 equal to 1 by 4. These are the roots of the given quadratic equation 8x square plus bx plus c is equal to 0. So sum of the roots is equal to minus b by 8 and product of the roots is equal to c by 8. So from these we get value of b is equal to minus 34 and value of c is equal to 8. So value of c minus b is equal to 42. So the option A is correct. Seventh question, let lambda is not equal to 0 be in R, that is real number set. If alpha and beta are the roots of the equation x square minus x plus 2 lambda is equal to 0 and alpha and gamma are the roots of the equation 3x square minus 10x plus 27 lambda is equal to 0, then beta gamma upon lambda is equal to. These are the options given. This question was asked in JEE Mains 2020. It is given that alpha and beta are roots of the equation x square minus x plus 2 lambda is equal to 0. So we can write alpha plus beta is equal to 1 and alpha beta is equal to 2 lambda. Also, it is given that alpha and gamma are roots of the equation 3x square minus 10x plus 27 lambda is equal to 0. So alpha plus gamma is equal to 10 by 3 and alpha gamma is equal to 9 lambda. It is given that alpha is one root of the equation x square minus x plus 2 lambda is equal to 0. So x is equal to alpha should satisfy this equation. That means alpha square minus alpha plus 2 lambda is equal to 0. Also, it is given that alpha is one root of this equation as well. So x is equal to alpha should satisfy this equation as well. So 3 alpha square minus 10 alpha plus 27 lambda is equal to 0. We can solve equation number 5 and 6 to get alpha is equal to 3 lambda. Put the value of alpha in equation number 1 to get the value of beta is equal to 1 minus 3 lambda. Put the values of alpha and beta in equation number 2 to get the value of lambda is equal to 1 by 9. Now put the value of lambda in equation number 8 and 9 to get the values of alpha and beta. So alpha is equal to 1 by 3 and beta is equal to 2 by 3. Now from equation number 4, put the value of alpha and lambda to get the value of gamma. So gamma is equal to 3. Now we have got the values of beta, gamma and lambda. So beta gamma upon lambda is equal to 18. So option D is correct. 8th question, if alpha and beta are distinct roots of the equation x square plus 3 to power 1 by 4x plus 3 to power 1 by 2 is equal to 0, then the value of alpha to power 96 into alpha to power 12 minus 1 plus beta to power 96 into beta to power 12 minus 1 is equal to. These are the options given. This question was asked in JEE Mains 2021. The given equation is x square plus 3 to power 1 by 4x plus 3 to power 1 by 2 is equal to 0. Put 3 to power 1 by 4 is equal to t so that calculation will be easier. So the given equation will be x square plus tx plus t square is equal to 0. Its roots alpha and beta can be calculated by the formula minus b plus minus under root b square minus 4ac upon 2a. So the roots will be minus t plus minus under root 3ti by 2. Suppose alpha is equal to minus t plus root 3ti by 2. So beta will be equal to minus t minus root 3ti by 2. Alpha can be written as, take t common here, so in bracket it will be minus 1 by 2 plus root 3 by 2i. Minus 1 by 2 can be written as cos 2 pi by 3 and root 3 by 2 can be written as sin 2 pi by 3. So alpha is equal to t into cos 2 pi by 3 plus I sin 2 pi by 3. Similarly, beta can be written as, take minus t common here. So it will be minus t into in bracket 1 by 2 plus root 3 by 2i. 1 by 2 can be written as cos pi by 3 and root 3 by 2 can be written as sin pi by 3. So beta is equal to minus t into cos pi by 3 plus I sin pi by 3. Now we are ready to calculate alpha to power 12, alpha to power 96, beta to power 12 and beta to power 96. Alpha to power 12 is equal to t to power 12 into cos 2 pi by 3 plus I sin 2 pi by 3 to power 12. We can apply the Darboux theorem in this part. So power will be multiplied with the angles. So this part will be cos 8 pi plus I sin 8 pi. This is in the form cos 2n pi whose value is 1. This is in the form sin 2n pi whose value is 0. So alpha to power 12 is equal to t to power 12 into 1 plus 0 and that is equal to t to power 12 and t is equal to 3 to power 1 by 4. So alpha to power 12 is equal to 27. Similarly, we can calculate alpha to power 96, beta to power 12 and beta to power 96. So the value of alpha to power 96 into alpha to power 12 minus 1 plus beta to power 96 into beta to power 12 minus 1 is equal to 52 into 3 to power 24. So the correct option is option C. 9th question, if alpha and beta are the roots of the quadratic equation x square plus x sin theta minus 2 sin theta is equal to 0, where theta lies between 0 to pi by 2, then alpha to power 12 plus beta to power 12 upon alpha to power minus 12 plus beta to power minus 12 into alpha minus beta to power 24 is equal to. These are the options given. This question was asked in JEE Mains 2019. It is given that alpha and beta are roots of the quadratic equation x square plus x sine theta minus 2 sine theta is equal to 0. So we can write alpha plus beta is equal to minus sine theta and alpha beta is equal to minus 2 sine theta. The given expression is alpha to power 12 plus beta to power 12 upon alpha to power minus 12 plus beta to power minus 12 into alpha minus beta to power 24. We will simplify this expression first. Alpha to power minus 12 can be written as 1 by alpha to power 12. Similarly, beta to power minus 12 can be written as 1 by beta to power 12. We will take LCM of this part, and the LCM will be alpha to power 12 into beta to power 12. In numerator, it will be beta to power 12 plus alpha to power 12. Now, alpha to power 12 into beta to power 12 will go into numerator, and this part will get cancelled. So, expression is simplified as alpha to power 12 into beta to power 12 upon alpha minus beta to power 24. Alpha to power 12 into beta to power 12 can be written as alpha beta whole to power 12. And alpha minus beta to power 24 can be written as alpha minus beta whole square whole to power 12. Now we will use this identity. Alpha minus beta whole square is equal to alpha plus beta whole square minus 4 alpha beta. Value of alpha plus beta and alpha beta we will put from equation number 1 and 2. So alpha minus beta whole square is equal to sine square theta plus 8 sine theta. Now we will put the values of alpha beta and alpha minus beta whole square from equation number 2 and 3. So the expression is simplified further as 2 to power 12 upon sine theta plus 8 to power 12. So option D is correct. 10th question. Let alpha and beta be two real numbers such that alpha plus beta is equal to 1 and alpha beta is equal to minus 1. Let Pn is equal to alpha to power n plus beta to power n. Pn minus 1 is equal to 11 and Pn plus 1 is equal to 29. For some integer n is greater than or equal to 1. Then the value of Pn square is. This question was asked in JEE Mains 2021. It is given that sum of the roots is equal to 1 and product of the roots is equal to minus 1. So the quadratic equation will be x square minus sum of the roots into x plus product of the roots is equal to 0. So quadratic equation will be x square minus x minus 1 is equal to 0. Alpha is one root of this equation. So x is equal to alpha will satisfy this equation. So we can say that alpha square minus alpha minus 1 is equal to 0, or alpha square is equal to alpha plus 1. 1 can be written as alpha to power 0. So in terms of power, it can be read as alpha to power 2 is equal to alpha to power 1 plus alpha to power 0. Now replace 2 by n plus 1. So alpha to power n plus 1 is equal to alpha to power n plus alpha to power n minus 1. When n is equal to 1, this will be true. Now beta is another root of the same equation. So in the same way, we can say that beta to power n plus 1 is equal to beta to power n plus beta to power n minus 1. It is given that Pn is equal to alpha to power n plus beta to power n. So Pn plus 1 is equal to alpha to power n plus 1 plus beta to power n plus 1. And Pn minus 1 is equal to alpha to power n minus 1 plus beta to power n minus 1. Now we can add equation number 3 and 8. So on the left hand side, it will be alpha to power n plus 1 plus beta to power n plus 1. And on the right hand side, it will be alpha to power n plus alpha to power n minus 1 plus beta to power n plus beta to power n minus 1. Now alpha to power n plus beta to power n is equal to Pn. Alpha to power n minus 1 plus beta to power n minus 1 is equal to Pn minus 1. And alpha to power n plus 1 plus beta to power n plus 1 is equal to Pn plus 1. So Pn plus 1 is equal to Pn plus Pn minus 1. It is given that Pn plus 1 is equal to 29 and Pn minus 1 is equal to 11. So Pn is equal to 18 or Pn square is equal to 18 square, and that is 324. So we will fill 324 here. 11th question. Suppose A and B denote the distinct real roots of the quadratic polynomial x square plus 20x minus 2020, and suppose C and D denote the distinct complex roots of the quadratic polynomial x square minus 20x plus 2020. Then the value of AC into A minus C plus AD into A minus D plus BC into B minus C plus BD into B minus D is. These are the options given. This question was asked in JEE Advanced 2020. It is given that A and B are roots of the quadratic equation x square plus 20x minus 2020 is equal to 0. So we can write A plus B is equal to minus 20 and AB is equal to minus 2020. It is also given that C and D are roots of the quadratic equation x square minus 20x plus 2020 is equal to 0. So we can write C plus D is equal to 20 and CD is equal to 2020. The given expression is AC into A minus C plus AD into A minus D plus BC into B minus C plus BD into B minus D. First, we will open the brackets, then regroup the terms so that we can utilize these values. So when we open the bracket, this expression will be A square C minus AC square plus A square D minus AD square plus B square C minus BC square plus B square D minus BD square. If we pair up the terms A square C and A square D, we can take A square common so that in bracket it will be C plus D. We can put this value of C plus D is equal to 20. The same idea is extended for other terms as well. We will pair up the terms like this. A square C plus A square D minus AC square plus BC square minus AD square plus BD square plus B square C plus B square D. Now we will take common. So in term 1 and 2, A square is taken common, so it is C plus D minus C square into A plus B minus D square into A plus B plus B square into C plus D. Now we will put the values of A plus B and C plus D from equation number 1 and 3. So the expression will be simplified as 20 into A square plus C square plus D square plus B square. Now we will pair up these terms, A square and B square and C square and D square. So the expression is written as 20 into A square plus B square paired up plus C square plus D square paired up. Now to get the values of these, we will use the identity A square plus B square is equal to A plus B whole square minus 2AB. Value of A plus B and AB we will put from equation number 1 and 2. So A square plus B square is equal to 400 plus 40. Similarly, C square plus D square is equal to C plus D whole square minus 2CD. Value of C plus D and CD we will put from equation number 3 and 4. So C square plus D square is equal to 400 minus 40. So the value of expression will be 20 into A square plus B square is 400 plus 40 plus C square plus D square will be 400 minus 40. So finally, value of the expression comes out to be equal to 16,000. So option D is correct. Last question. Let alpha and beta be the roots of x square minus x minus 1 is equal to 0 with alpha greater than beta. For all positive integers n, define an is equal to alpha to power n minus beta to power n upon alpha minus beta, where n is greater than or equal to 1. b1 is equal to 1 and bn is equal to an minus 1 plus an plus 1, where n is greater than or equal to 2. Then which of the following options are correct? These are the 4 statements. We have to verify which statement is correct and which is not. There may be more than one correct statement. This question was asked in JEE Advanced 2019. It is given that alpha and beta are roots of the quadratic equation x square minus x minus 1 is equal to 0. So we can write alpha plus beta is equal to 1 and alpha beta is equal to minus 1. Statement A. A1 plus A2 plus A3 plus and so on up to An is equal to An plus 2 minus 1 for all n is greater than or equal to 1. It is given that An is equal to alpha to power n minus beta to power n upon alpha minus beta. So put n is equal to 1. So A1 will be equal to alpha minus beta upon alpha minus beta. A2 will be equal to alpha square minus beta square upon alpha minus beta. A3 will be equal to alpha cube minus beta cube upon alpha minus beta, and so on. So A1 plus A2 plus A3 plus and so on up to An is equal to alpha minus beta plus alpha square minus beta square plus alpha cube minus beta cube plus and so on up to alpha to power n minus beta to power n upon alpha minus beta. Now numerator can be written as alpha plus alpha square plus alpha cube plus and so on up to alpha to power n minus beta plus beta square plus beta cube plus and so on up to beta to power n. Now these are two GPs with n terms. So sum of n terms of a GP series is given by the formula A into 1 minus r to power n upon 1 minus r, where A is first term, r is the common ratio and n is the number of terms. So sum of this GP series will be equal to alpha into 1 minus alpha to power n upon 1 minus alpha. And sum of this GP series will be equal to beta into 1 minus beta to power n upon 1 minus beta. Value of 1 minus alpha is equal to beta and value of 1 minus beta is equal to alpha from equation number 1. Now we will take LCM of denominator. So it will be alpha beta. So numerator in bracket will be alpha square into 1 minus alpha to power n minus beta square into 1 minus beta to power n. So it can be simplified as alpha square minus beta square minus alpha to power n plus 2 plus beta to power n plus 2. Alpha square minus beta square can be written as alpha plus beta into alpha minus beta. And value of alpha beta is equal to minus 1 from equation number 2. So this can be simplified further as alpha to power n plus 2 minus beta to power n plus 2 minus alpha plus beta into alpha minus beta upon alpha minus beta. Now we can separate this into two terms. So first term will be alpha to power n plus 2 minus beta to power n plus 2 upon alpha minus beta minus second term will be minus alpha plus beta. Value of alpha plus beta is equal to 1 and this is equal to an plus 2 from here. An is equal to alpha to power n minus beta to power n upon alpha minus beta. So an plus 2 is equal to alpha to power n plus 2 minus beta to power n plus 2 upon alpha minus beta, which is the same. So this can be simplified as an plus 2 minus 1, which is right hand side. So statement A is correct. Statement B. Summation of an upon 10 to power n from n is equal to 1 to infinity is equal to 10 by 89. Left hand side is summation of an upon 10 to power n from n is equal to 1 to infinity. Given that an is equal to alpha to power n minus beta to power n upon alpha minus beta. So this is equal to summation of alpha to power n minus beta to power n upon alpha minus beta into 10 to power n from n is equal to 1 to infinity. Now this can be split into two terms. Take 1 upon alpha minus beta outside. So inside the bracket it is summation of alpha to power n upon 10 to power n from n is equal to 1 to infinity minus summation of beta to power n upon 10 to power n from n is equal to 1 to infinity. This can be expanded as alpha by 10 plus alpha square by 10 square plus alpha cube by 10 cube plus and so on up to infinity. Put the values of n as 1, 2, 3 and so on up to infinity. Similarly, this can be expanded as beta by 10 plus beta square by 10 square plus beta cube by 10 cube plus and so on up to infinity. This is infinite GP series and this is also infinite GP series. Sum of an infinite GP series is given by the formula A upon 1 minus R, where A is first term and R is the common ratio. So sum of this infinite series will be equal to alpha by 10 upon 1 minus alpha by 10. And sum of this infinite series will be given by beta by 10 upon 1 minus beta by 10. This is simplified as alpha upon 10 minus alpha, and this is simplified as beta upon 10 minus beta. Now we can simplify further up to this point, 10 upon 100 minus 10 into alpha plus beta plus alpha beta. Values of alpha plus beta and alpha beta we will put from equation number 1 and 2. So finally the value comes out to be equal to 10 by 89, which is right hand side. So statement B is also correct. Statement C, summation of bn upon 10 to power n from n is equal to 1 to infinity is equal to 8 by 89. Left hand side is summation of bn upon 10 to power n from n is equal to 1 to infinity. Given bn is equal to an minus 1 plus an plus 1. So this is equal to summation of an minus 1 plus an plus 1 upon 10 to power n from n is equal to 1 to infinity. An minus 1 is equal to alpha to power n minus 1 minus beta to power n minus 1 upon alpha minus beta. And an plus 1 is equal to alpha to power n plus 1 minus beta to power n plus 1 upon alpha minus beta. So this can be simplified as alpha to power n minus 1 plus alpha to power n plus 1 minus beta to power n minus 1 minus beta to power n plus 1 upon alpha minus beta into 10 to power n from n is equal to 1 to infinity. Now this can be split into 4 terms. Take 1 upon alpha minus beta outside. So inside the bracket it is summation of alpha to power n minus 1 upon 10 to power n from n is equal to 1 to infinity plus summation of alpha to power n plus 1 upon 10 to power n from n is equal to 1 to infinity minus summation of beta to power n minus 1 upon 10 to power n from n is equal to 1 to infinity minus summation of beta to power n plus 1 upon 10 to power n from n is equal to 1 to infinity. This can be expanded as alpha to power 0 upon 10 plus alpha upon 10 square plus alpha square upon 10 cube plus and so on up to infinity. Put the values of n equal to 1, 2, 3 and so on up to infinity. Similarly, these all can be expanded like these. These 4 are infinite GP series whose sum is given by the formula A upon 1 minus R, where A is first term and R is the common ratio. So here first term is 1 by 10 and common ratio is alpha by 10. So this is 1 upon 10 upon 1 minus alpha by 10. Similarly, we can find the sum of other infinite GP series. So this can be simplified as 12 by 89. But right hand side here is 8 by 89. So this statement is wrong. Statement D. Bn is equal to alpha to power n plus beta to power n for all n greater than or equal to 1. Left hand side is Bn and given Bn is equal to an minus 1 plus an plus 1. An minus 1 is equal to alpha to power n minus 1 minus beta to power n minus 1 upon alpha minus beta. And an plus 1 is equal to alpha to power n plus 1 minus beta to power n plus 1 upon alpha minus beta. Take 1 upon alpha minus beta common. So inside the bracket it is alpha to power n minus 1 plus alpha to power n plus 1 minus beta to power n minus 1 minus beta to power n plus 1. If we can replace this by alpha minus beta into alpha to power n plus beta to power n, then alpha minus beta will get cancelled and right hand side will be equal to alpha to power n plus beta to power n. So statement D will be correct. So let us multiply and verify. Left hand side is alpha minus beta into alpha to power n plus beta to power n. So after multiplication it will be alpha to power n plus 1 plus alpha beta to power n minus alpha to power n beta minus beta to power n plus 1. Take alpha beta common in term 2 and 3. So inside the bracket it is beta to power n minus 1 minus alpha to power n minus 1. Put the value of alpha beta is equal to minus 1 from equation number 2. So it is simplified as alpha to power n minus 1 plus alpha to power n plus 1 minus beta to power n minus 1 minus beta to power n plus 1, which is right hand side. So we can replace this by alpha minus beta into alpha to power n plus beta to power n. So alpha minus beta will get cancelled, and right hand side is equal to alpha to power n plus beta to power n. So here the right hand side is same. So statement D is also correct. So finally, correct statements are A, B and D. In next video, we will start chapter number 5, and that is permutations and combinations. If you have a question, you can ask me on my Discord server. If you have not subscribed my channel yet, please do so.